Okay, so what we'll actually cover in this one is, I will actually very basics. We'll start with the basics of what is the data, analytics, and insights, and how the analytics are converting into the insights and helping us to take the right decision for the business, right? And in that context, what are the goals? What are the jobs that are emerging as a result, and what are the tools that we are actually using in this one, and then which one actually created jobs. So whole intention for us to upskill here is we actually get right job for our the skills, right? So yeah, fundamentals, right? So let's go through the very fundamentals. These are from the dictionary book, right? So what is the data, and then what is the database, how we are actually getting the facts of the something which is called the information, then by doing a systematic analysis on the data that has been there, which is called the analytics. So how we are going to use the analytics to get the insight, so that actually gives the real value for us to make the things. And then now you see the data science is a concept. Please keep it in mind. It's not a view. So it is a concept to unify multiple. Something with statistics, data analysis, and machine learning. All three of them, each of them individual. Each of them individually have the different level of the skills that is required to be experts in those areas, and then how they are actually converting and then resulting us to become a data scientist. So we'll go through the details, and then we'll actually see what is the first we need to understand, right, where this whole concept of the big data is coming up. So why do we need a machine learning? Why do we need a different tools for doing all these things? So it's all because the data is actually growing very rapidly. So if you notice, so all of us use different mobile devices. So all of them actually generate huge amount of the data, and if you notice over the years, right? So from a very broad way, if you see the history of the data that has been accumulating from the business institutes. So every time, so this year is generating the whatever the data that has been generated in the past. So that means the growth is multi-dimensional, and multi-folds the data is growing and then creating the one is the two aspects when the data growth happens, right? One is the challenge that actually possesses how to process this one, how to get a quick insights out of it, and the second way is the other side of the challenge is when there is too much of data coming inside, how we actually make use of that data. So one is handling the data, second one is making insights quickly out of the data. So in this process there is a lot of data that may not be required for you for the analysis, right? How to curtail the data and then make quickly what you wanted and then do a real-time analytics. So that is the key you need to understand for making the value out of that one. So in this case, see the top one, right? From an internet emerging everybody and then having the connectivity to whole lot of the population. So huge amount of things are happening every second, and then the real-time data has been growing much faster. So similarly, the key characteristics of the big data is, so 5 V's. What you see, right? The volume, that's the raw data that has been growing very quickly, and change over time, the velocity, right? So what is the rate at which the data is being changing, and then the data types, it's like the number of different varieties of the data, be it structured data, unstructured data, the volume, and then the images, the videos, audios, the various amount of the data, right? That is posing the challenges for us to process that data efficiently, right? And the biggest problem in the whole of this data journey is maintaining the data quality. So how much quality the data is, that much the quality the results come, right? So if you put a garbage in, garbage out kind of stuff. So you need to ensure whatever the data that we are actually processing, that need to have properly transformed, aligned, and then get the right quality into the data, so that we can actually get the right insights. And then the last V, the recently added, is how value we are actually creating out of the data that we are actually processing. Then you see some of these critical industry sources on a day-to-day life. So how they are actually adding a lot of data in a real time, right? So you see the first one, so oil and gas industries. For any of the automated industries, right? They tons of sensors across the board, so they actually generate a real-time data. So they actually use for multi-purposes, right? So these all of them huge inventories, and then every time if any of the machinery goes down, that actually causes a huge amount of the loss. So you need to ensure that, okay, proactively you need to maintain all these systems up and running. So for that one, you need to have a right level of sensors that collect the data, and then you real-time monitor and then proactively take the actions, so that everything is up and running all the time. The secondly, so most of these surveillance takes, so across the cities, across the offices and businesses, we see that a lot of the surveillance cameras, and then they are taking. And we have actually the number of solutions that are coming up to take care of the real-time solutions, real-time analytics, and then give them alerts to that one, and also the take the triggers for what kind of data that we are actually storing for the further analysis. And similarly, the smart metering. This is one of the area which is actually growing much faster. We have seen actually a lot of development in this area. Say for example, most of our household and then the areas, so we have a lot of meters, be it an electricity meters or water meters or various other type of utility consumptions, right? So all of them now they are getting an automated. Earlier somebody used to come manually, record the data, record the readings, and then generate enter into the systems, and then they generate the billing, and then that comes, right? Now it is more or less, so smart metering systems are coming, and then they are all becoming automated, and then they generate real-time billing systems. So you can know at any point of time what is your consumption, and then the what you can actually control and then adjust. So the other one is, the biggest contributor is the healthcare. So if you notice that an ICU or something, so number of monitoring that is happening, and then they generate a huge amount of things. And now you create an application on top of that, like our Watson Health. So for various things, so you can actually proactively alert the doctors, proactively alert the attendance staff, not to miss any of the alarming things that are happening during the monitoring, right? So some of them are through the alert basis, some of them actually come back into the deeper level, and then they actually suggest us, so how and then what is happening here. So this could be a new pattern that is emerging, and then there is a problem that we can actually solve. So like that there are number of automated IoT devices that are actually making enormous amount of data that is generated into the systems. So as a result, where the shift is happening in the industry is, so what used to be there when we joined in the industry, so it used to be just like in every organization they collect the data, and then the CEOs or the CFOs or the CXOs, all of them, so they actually predefine the reporting structures, what they want exactly there. So they used to tell their IT team saying that, okay, I want these reports by end of this week, or end of day, or end of week, or end of month, or end of quarter, like that. So what does that mean is, it is a predefined things that are actually given to us, and then we used to code and then prepare the documents and then the reports ready for them. So that they use for the taking the decision for the business expansion and then the business development and all. But if you notice over the time, what is happening is all of that is being automated, which means that is the threat for the whole of the jobs in the current, the way we are actually doing versus what is going to be the case. So these platforms are getting automated, whatever they need it is available as a platform automation itself, and then no developer required for generating that data ready for the as a platform for the people. Now the shift is happening on the business side. So the whole of the platform is ready. Now we as a employees for the organizations, right, we need to make a change in taking the right decision or the finding the right patterns or right insights from the data and then giving the insights to the executives to take the right decisions, which is actually very fundamental shift. You are going to understand more from a business side and more from the data engineering side. It's like what is the new pattern that is coming up. It's not that okay, commonly available report structure for each of the CEOs. You are creating a new thing that CEO also might have not thought. So that is where actually we are going to differentiate and then make value if we want to be a real valuable employee in that organization. It's not that okay, somebody is directing you and then we are going to build that one and then give it. So then it is actually a monotonous job, and then on top of that one, it is just anybody can get it. So you are not competitively differentiating because the other competitor also will get that type of data, right? So for us to be competitively different, the way we analyze the data to be differentiated. That's where the whole of the analytics and then the data science come into the picture. See, the most of this one also, if you notice, so what we used to do is like all the advertisement world, if you have noticed, so we used to publish a lot of the facts and then common for the entire world. It's like you just publish in the mode that okay, it's a group of the people and everybody gets that okay, we have actually these are the specializations and all. Now we are actually adding the better features of our product, linking to the needs of the individual and then targeted ways. So we actually change the real-time advertisement mode and then we actually reach out to for the marketing. The go-to-market strategies are changing. So those strategies actually individualized and then they actually take the value out of the things. And then your success rate for the reach percentage-wise actually increase. So in that aspect, a lot of social media coming into the picture where you are actually knowing the interests of the people and then aligning that one to the merits of your product and then combine this. So that's where the changes are coming, and then unless we actually give these analytics as a data scientist in the organization, so that is not going to be the key change for them, right? So this slide, what it actually gives us is what are the different kinds of scenarios that can actually exist in the system, and then they actually make change, right? The top one, if you see, so it is actually the data center, right? So for everything that we reach out to the data centers, for irrespective of the business line, so if there is a problem, we actually reach out to the data centers, and that is where actually the lot of the automation and the customer satisfaction actually makes a lot of difference from there. So you get a faster solutions when you call a call center, then you feel more confidence on the product you are buying. So that is the key difference. That when you can expect that one is only in a case where you are analyzing the pattern of the problems and then finding a common solutions and then giving them a readily available the moment they reach to you. So it needs to go to a call center employee to answer personally, but you can actually make all of them continuously monitor and continuously patternize and then create a facts or create a automated responses for different kinds of problems, and then your IVRS itself can solve the half of the things and by automation things, and then that is an accurate and then perfect. So it will actually save a lot of time and then a lot of employment, and then which will actually save the cost and time. And then the next level is the hospitals, right? So that we have already talked in the last slide. So a lot of monitoring is coming into the picture, and a lot of especially if you notice, even the Manipal hospitals, right? So recently they have collaborating with an IBM Watson Health for their oncology missions, and then they are taking a lot of research and then assistance area from the Watson for taking the decisions for different patterns of within the cancer patients. So that way, the healthcare is another area where a lot of data analytics come into the picture. Now the weather prediction, everyone knows this is purely based on the amount of data that actually gets collected, and then that data actually processed in the systems. So it's purely a grid based across the world. The more the data that is available for the closure basis, the better the accuracy in your predictions, which is again data intensive for the processing, for the modeling. So there are a lot of parameterization happens, and then based on the terrain, based on the place where it is, and whether it is in tropical regions or extratropical regions. So based on all those parameters, you will actually have the lot of things, and then again huge data intensive part. And risk analytics, so which is across the board actually, be it in your banking industry or the government industries, or even including the IT industries, right? There are a lot of processes we actually follow, and then each of the process, how well we are actually following, so they need to be monitoring the risk assessments. So that is where actually it comes comes to the quality of the organizations that they are delivering the services. So that's again another area of massive real-time data monitoring, and then the giving the alerts. And the last one is identifying the criminals and the fraud transactions in the things, and counter fraud management or the immigration management in linking to the people's identity. So this is all actually the number of scenarios that where the big data and then the real-time analytics that are all going to play a key role, and which has a direct impact to the society. So that the connectivity is very important. The moment, unless we solve the problem, whatever the skill that we actually gain, which has no value. Only the value we can realize is the skill we are gaining from a fundamental sciences and the computers. So if combined together and then solve a real-time problem, that actually has the business potential, and then that actually results of the benefit to the society as well as ourselves. The pride feeling will come only when you convert your skill into solving a real-time business problem. So as a data scientist, you can always actually do that one, and this is actually unlike the earlier days, right? So when we were actually doing a coding and then creating a problem, the boundaries are limited. So you can only do so much. But when you are actually as a data scientist, the boundaries are unlimited. You can create a new pattern, or you can actually identify a new way the things can be solved. So the opportunities are very high. The moment you actually start thinking and then putting your brain, the more and more opportunities you can create for your organization to benefit. So that's where the endless opportunity comes in as a data scientist versus the previous mode of an information technology specialist. There's a key differentiation between those two. So if you see this one, so why I have actually come up this one is, what are the different types of analytics that we have, right? So each of them, how they are actually be useful, and what problem that they are actually starting. Say for us, let us start with the descriptive analytics, which is actually what it does is, so which has been very, very famous, and then everybody well known this area, where what has happened based on the data that is being in the systems. So we have the enough data, and then we know that okay, what must have happened there by analyzing those ones and then creating the reports of that. Traditionally, what we used to call this is business intelligence. So all our Cognos, Tableau, so like that there are a number of tools, right? Business objects. They all are, what they are actually helping us is actually creating the reports and then telling that okay, what has happened in the system. That's the kind of, so all of them are important. So only thing is how they are evolved, and then how they are converting and then taking us to a cognitive mode where we are actually going to the next level of the value creation to the business running. So the next one, if you go, the predictive analytics, right? The predictive analytics part. So understanding the future. So previously what we actually learned is what happened in the past, and then now in the predictive analytics part, what we need to do is like what's going to happen. Based on the past, what we have actually the data. So how we are going to predict based on the creating some models and then coming up with the. So there are again what's likely to happen, right? So for example, so how the real-time examples, if you notice, all of us gets the credit score, right? So the credit score actually tells that what is the potential you are actually having to pay the your bank loans returns. So which actually based on your past history, they are creating a score that is going to predict your capability to repay the balance. So that's how this predictive modeling is going to help for the businesses. So like that weather prediction or profit loss. So all the companies, right, based on their past history, one. Second one is actually what they are projected. So in each of their sales, each of their inventories, each of their things, they actually predict their profit loss and then the EPS kind of stuff. So that will actually help them with this. The next one is a perspective analytics. So what does it is like, what should I do next? So I know what happened, and I know that okay, what's going to happen. How do I make this in a better way? What are the things that I need to optimize to do the better things? So what are the business rules that I need to impose here for me to get an alert, and then that gets optimized and then gives me the better results, right? So that's where if you see the true examples are the dynamic pricing. Dynamic pricing in the areas of the airlines, we always see now that has been applied to the railway ticketing. So there are many things actually. So even that can be applied to IPL ticketing or many other movie ticketing like that. So that actually gives us what is the workload or the demand that is getting generated. Based on the demand, I can actually make my profitability increased. So that is a real time you are helping your businesses to do much better and based on the demand. So like that there are what is the time for me to launch the product. So sometimes this movie launch timings are very critical, right? So they actually lose because they are not launching or releasing the movie on the right day. So that actually creates an impact to their revenues collections. So like that. So I'm trying to give in each of the perspective and in each of the analytics area which real time they're going to helpful. So these all are possible. And then what are the associated tools? So if you notice in all the areas I've given the what tools are actually useful. And then why I am giving the tools is the concepts are not going to give us the jobs. So in the market, unless you know the right tool to choose and then create the value or the solution, so that is what actually going to create us the jobs. So that means you need to understand the usage of the tools that are going to give you the job market. So that's why I've given some of the tools as well. So there are enough number of tools in the open market as well, or the open source, which is the next level of means like the everybody's choice to choose, right? So you need to understand in each of the area. So what is the open source tool that available, and then you can actually pick up that skill. And the last one is the cognitive one. So cognitive one. So everywhere we actually hear the cognitive as the top line item these days. So what exactly it does is it's a combination of using the machine learning, using the natural language processing, and then understand and then learn by the things that are happening by itself, and then improving further and then suggesting you with a new approach to adopt in the business. So if you see what can I learn from what happened. So if you see some of the applications, so Jeopardy, Chatbot, Siri, Google Assistant. So these all are actually examples of the things, and then the IBM Watson is the key example for that one. We have a number of APIs exposed in the various areas like the behavior analysis, personality analysis, or the predicting scores, or many other areas. So which you can actually make use of the Watson in the cognitive area, and then develop these chatbots and many of the real-time problem solving applications. So these are the few key metrics from an India perspective on the business analytics in India. What is the real size of this one? Out of this one, what we are actually delivering in India, within India, and then what are the metrics that we are actually going to use means it's serving for the other outside India. Especially we still, if you notice, majority of the analytics area we are serving still to the Western world, not within India. So most of the services for the finance and banking and then the telecom areas that are leading, but we are actually going back and then serving the worldwide thing. But the growth rate in Indian consumption is growing much faster than what we are expecting. So that is actually key metric for us, all of us to be ready to solve the real-time problems in analytics and then help our businesses to grow the multifold. Especially when we are expecting our GDP growing maybe double digit very soon. So that is the place and then the point where we all become critical to take this mission to the next level and then support the domestic demand that is coming in all aspects, be it in a financial industry or the hospitality industry, and then the third one is the healthcare industry. So all three of them are going to be critical. And the other one which you notice, so in India in the last 3-4 years, the sports is becoming one of the prime area, so which has a humongous opportunity for the analytics in the sports. So that's another area which you need to keep it tight. So there are different types of all these analytics that we talked about in the previous slide. All of them are used in the sports industry as well. So different places, different kinds of the analytics that are used to make the business out of the sports and the entertainment more valuable to the industry. So far what we did it is we've touched some of the things in broadly understanding the different kinds of analytics and then where they are actually useful in the system. But now I'm actually coming to the real way, what exactly happens in the life cycle to make a analytics driven from the raw data. So one is the first one is what is the data that is actually needed, right? So once you have your business need is defined, then you actually go and then find out all the sources of your data. So acquiring the data itself is a very interesting topic, and then because your sources are multi-dimensional, and then each one has some places you will actually get a physical record still, some places you will actually get the dynamic social media records in the real time, some of them in audio format, video format, or various text formats, and then some of them in a structured databases. So how you are actually collaborating means like acquiring them and then ensuring that all of them are available for you to process further, right? So that is where actually they analyze the data and then what are the how to predict based on the data, right? So this is the cycle actually goes. So whatever the cycle that we have talked, right? And then finally it becomes an iterate. So what you learn from the so far the analysis, and then you actually tune your model in such a way that okay, in the next phase of the data you are actually injecting, that actually applies this tuned model so that you continuously iterate, continuously better the process. So it's not easy, right? Always when you are actually interactions between the different teams in the organization. So if you see the IT team and then the data scientists and statisticians or the business users or the business analysts, so everybody has a different context to understand the problem, and then all of them actually coordinatively or collaboratively work together to make sense out of your data. So to make sense, and then that insight that is actually helpful to the platform, right? It's not easy. So that's why I'm trying to see that okay, what kind of places the interactions happens. In each of the interaction, so they have to actually take multiple actions to address. So now this is actually an IBM story that I'm bringing up and then actually collating to the real-time problems. How we have actually segregated our data analytics portfolio in such a way that okay, this addresses the entire portfolio, gamut of the whole problem, right? So the first and foremost is you need to collect the data from various sources, right? This is called the hybrid data management. So from different sources, how efficiently your data repositories can actually integrate together and then make your data things. So which is actually transactional databases, or OLTPs, or OLAPs, or your NoSQL databases. So like the number of different sources your data actually coming, all of them how efficiently you can, and then we have actually the number of tool sets that actually help you to capture all the sources and then address the problems of the data collection process. So the bottom line, if you see DB2 warehouse, DB2 event store, or the integrated analytics system, or DB2 Big SQL, Hortonworks and Hadoop platforms. So all of them are a typical IBM tool sets that actually helps for making the things happen. And then the next one is, once you have actually collected the data, the biggest problem comes is so much variant data that actually come and sitting in our systems. So how we actually organize them in such a way that is accessible for us to do the better governance, and then integrate all of them for the consumption by an end users. So that is the biggest job that we do. So combinedly in any of the data analytics world, if you see the collection and then organization itself will take more than 75% of your time for processing of all this data. So here we have actually the number of tools that actually helps you. Means like typically, if you have heard the ETLs, that is actually extract, transform, and then the load. So some of the tools actually helps us for integrating our data into our warehouses, and then they will actually helps to create a governing model, so that at the end, right, sometimes you actually do all these transformations and then you produce a report, and then if you are not able to trace back to the source where from it is coming, so it is of useless, and then authenticity and then the trust will actually lose on the data. So if you want to maintain and then ensure that, okay, what the report you generated out of the data that you collected, so you need to maintain that lineage, the data lineage right from the result to the source. So if you can actually maintain across this whole life cycle, so then only it will actually be a trusted data. So that's the key point here. You need to ensure what you report is actually linked to your source, so that the people actually give the trust. So the business glossary, and then information analyzer and all the tools, and governing catalog, and then master data management is another one. So which is mastering your mastering your data across the sources, and then ensuring that, okay, it's a single entity, and then which actually links to the different business points, and then you can actually reach out to the master, right? So the next part is the analyze the data. Once you have actually prepared your data ready to be consumed by the end customers, that's where the new job roles that we are talking about, right? So the analyze, the data science, and then the business analytics comes into the picture. Again, this is a vast area which we have actually seen the number of different things, and then all those analytics parts actually comes in the last area. So if you see SPSS, data science experience, Cognos, Watson Analytics, so Watson Explorer, all of them actually falls in this area to address the various challenges in the analyze part of the business. So it's just to give you, to get it exactly what is a Watson we call here, right? So what is the Watson? Watson is a platform. Okay, it is a technology platform. It's not a product. So please be mindful. The Watson is a name, and then the technology platform from IBM. So which actually uses the natural language processing and machine learning to analyze all types of the data, be it in structured or unstructured, and then provides you the various insights from your data. So that's a platform, and then that platform has n number of APIs, and then keep developing the new ones, and then you all actually can develop a new ones on top of the platform, and then make your customers to use those APIs as things. So this is a platform, gives you the opportunity for us to enhance further, for you enhance further, for all of us together to make the whole world get the better out of the platform. And then Watson Analytics is one of the offering on top of the Watson platform, where you can actually, it's a cloud-based and self-service based, simplistic analytics. The basic entry, if you want to do a cloud-based analytics, this is the easiest way. You load your data, and then it actually suggests you a number of different ways you can actually present this data, correlate the data with different stakeholders in the system or the business, and then the things, right, previously the fundamental shift that we talked earlier, right, the one is what we wanted to prepare a report is the way we used to work. So the system actually suggests you that, okay, there is a relation between these two things. You might have not seen that one. So why don't you look at this one and then see if that is going to be helpful for your new insight. So that is the kind of insights that Watson Analytics actually give you the hints, and then you go inspect, and then if it is a true factor and then the value addition, you can actually create that report and then make a differentiation from your competitor. So that's the difference between the traditional way versus the new way we are going to solve the problems. So this is a typical, like if you notice, right? So I'm coming from a very generic structure to the way we are actually going into the design method, the way we actually solve the overall problems, right? If you notice this one, so the top line actually shows the different job roles that exist, like a data steward, data scientist, data engineer, and the following slide actually gives a definition of each of this role. But what I wanted to give is at what stages of the our data life cycle, so each person comes into the picture, right? So especially when we are actually collecting the data and then finding the data and then modifying, so the data steward and then the data scientist comes into the picture. And then the data engineer actually comes where you actually the integrate the data, transform the data, and then make the data ready for the consumption by the various people. That's where the data engineer actually makes the coding part. And then the business analyst, so who is actually going towards the developer side, right? So the developer. So the developers are towards the end. The reason is you have actually the data already set ready with you, and then you are actually going to use the end customer in the different formats of the visualization that you are going to use. Be it mobile applications or web applications or the different forms of consumption. So you are actually using the different types of the programming languages or various different things to address the overall stuff. So that's where actually the developer comes there. So this is you can actually take a note. So who actually does what in the as a job role, right? So business analyst, so same thing. So you can actually go the new CXO title is the chief data officer, like chief security officer. Now chief data officer is coming because that's becoming so much value. You might have heard from our CEO. So last year is announcing that the data is the new natural asset for us. The value is like that. So we make in any business, right? We make money when we are actually using a natural element. So be it iron ore for processing or all our mining, right? So they all generate a huge amount because we are not buying that one. So for the world now, so the data is actually becoming a new natural resource for consumption and then preparing number of different products around it. So data is becoming a center for developing all your solution products. So that's where you need to understand that, the value of the data that's coming up. Okay, moving on to so the next one is, this actually gives a picture that, okay, what kind of skills that required for you to be a data scientist, right? So it is a combination of three different areas. One is, earlier we used to have all of them individually. Statisticians are different, business analysts are different, and software engineers are different. But in isolation, each of those ones are becoming an automated part. So the only thing when you are actually as a human, you are differentiating and then making more value in the system is you combine multiple skills, and then only it is going to be more opportunities. I'll go through the similar picture where the opportunity mapping to the roles and the domains. So that will actually give us how many number of opportunities that you can actually get it when you are actually acquiring and then exhibiting the multi-skills from these all three different domains. That means in you, a part of statistician, a part of mathematician, and then the IT programmer and business analyst, the more you actually as an individual possesses, the more actually you are bidding yourself for a better opportunity and then the roles. This is what I was talking. So the domain understanding is nothing but the business side of the things, and data science is nothing but your statistician and mathematical part of the engineering, and then the IT skills is actually software engineering, typical software engineering in the past. That's why there are no more software like an IT engineer positions are going to be emerging. So if I notice, even in my organizations, the more and more I see is like they're looking for a data scientist or data engineers or an advanced developers who can actually integrate these things much better than a traditional way of announcements. Traditional way, we used to have, I need a testing experts, I need a Oracle developers or Oracle administrations or DB2 administrators. Those are all the olden days of the jobs. You are not going to get such ones in bulk in future. So what you are going to get in bulk in future is actually the data engineering area. So whatever the job roles that we have seen, right? So number of those ones are going to give a better and then higher skills. So if you see the more the intersection, the dots you see, the more the opportunities you have to play roles. Okay, this is one slide I picked to give you an introduction on the next layers when you go. So what is an artificial intelligence, and then the machine learning, and then the deep learning, right? So how to see them as which one is a superset and then which is an embedded inside. So like that, right? So artificial intelligence is your outer side. So, and then which is actually the technique that that enable us for the computers and machines work together and then generates the value, right? So within that one, a subset is actually the machine learning, and then within the machine learning, some of the algorithms you take within the machine learning algorithm and then go inside the very deep, that's the deep learning. So that's how I just gave things. And the other area why I brought this one is when we were studying, right? So everyone used to ask me that, okay, did you know the Java or do you know the C? So those are the two languages which used to be very famous. I started my career as a core compiler developer. So for IBM C++ compilers, I used to take care of the part of the code generation and optimization area, where it is a typical C programming, and then that's how we started our careers 20 years back. So, but now if I go back and then see, so number of these languages are transformed over the years, and then they have become means like the foundations there, and then no more further development happening in those core areas. But if you see what is differentiating in the few new era languages, like different kinds of scripting, if you see Java, Angular, Java, or the different kinds of scripting, all of them actually integrating the foundations that are already available, the libraries that are available for the different functionalities, and then making more. The Python, this is when we started, it was not there. So it is slowly emerged to automate the build scripts, and then now it actually plays a key role across the board, be it data analysis or be it data automation or the builds things. So across the board, the Python is actually playing the key role. So one common language that can be used anywhere and everywhere. So if you know this language, so you can actually do multiple things. And then this has been supported by number of notebooks that are available as an UI platforms for the different languages. So you can actually use this one. Okay, this is just a last slide. I just wanted to give you a feel that, okay, how complex an enterprise architecture will be in the overall the analytics cycle. So where and the number of job roles that can emerge to do the different areas in that one. This will be the last slide. So I now open for the questions. Any questions, please?